Hey guys, and welcome back. We are on our very last lesson of this unit, and today we're going to continue our talk about inter versus intramolecular forces. Now, yesterday our lesson was all about polarity, so how to determine whether or not a bond is polar or nonpolar with the electronegativity, and we got a little bit of an intro into those inter and intramolecular forces. We're just going to call them IMFs for short, which is nice. But today we're going to go into those just a little bit more intensely, and then we will wrap up this unit. So without further ado, let's go ahead and get started. So just a reminder, intra means within. So our intramolecular forces are just going to be the bonds between our elements in a compound. So, or in a diatomic molecule like chlorine gas, oxygen gas, etc. So an intramolecular force is a force that holds atoms together within the compound or the molecule. So there are three types: metallic, ionic, and covalent. That's just a review of your bonds. We've already talked about them. So the intramolecular forces are just the bonds that occur between the elements. So remember, there are three types: metallic, where you have that sea of ions that's going to occur between either multiple atoms of the same metal or multiple metals. Ionic, between a nonmetal and a metal, where the electron is transferred. And then covalent, where you have two nonmetals and a sharing of electrons. Okay, so those are the intramolecular forces. Nothing new with those. We already know all about those bonds. So let's talk about the intermolecular forces. So these are the forces that are between molecules. Okay, so there are different forces that exist when we have these different molecules. So intermolecular forces hold them together. So there are three types. There's London dispersion, dipole-dipole, and hydrogen bonds. So the intermolecular forces are going to be London dispersion, dipole-dipole, and hydrogen bonds. So again, this is the new information that we're going over today, because you already know about the bond types, which are intramolecular. Now we're talking about the intermolecular. So all these forces are occurring between molecules. So the first thing we're going to talk about is hydrogen bonding. If you did not do your ENGAGE assignment from this morning or from earlier in the lesson, you need to go back and do that, because it's all about water and the properties of water, which you guys will need to know for your test. But in that video, we talked about hydrogen bonding, which occurs in water, but also other molecules with these elements as well. And hydrogen bonding occurs between molecules with hydrogen, nitrogen, oxygen, and fluorine. Okay, so that means if there's a hydrogen in the molecule and then that hydrogen is bound to one of these three elements, then a hydrogen bond exists. Now this is water right here. So we have H2O, 2 hydrogen, 1 oxygen. The covalent bond is existing between the hydrogen and the oxygen in the individual water molecule. And then we're having that hydrogen bond existing between the hydrogen and the oxygen of other molecules. So this would be one hydrogen molecule or one water molecule here that are held together covalently between the bonds of their individual hydrogen and oxygen. But then also all those molecules interact with each other via this hydrogen bond as well. This is the strongest IMF. So the strongest of any are going to be the bonds themselves. So covalent, ionic, metallic, those bonds are stronger than anything else we're talking about today. But out of the three new ones we're talking about, the hydrogen bonding is the strongest. Okay, and then water is a good example. So hydrogen bonding in water is basically, it's what gives it all of its unique properties. Again, in that engagement activity that you guys did earlier in the lesson today. So hydrogen bonding is the reason, number one, that hydrogen bonds or that water itself has a high specific heat, meaning that it takes more energy to boil water, to have it vaporize and go through that phase change from a liquid to a gas. So It helps give water its high specific heat because those hydrogen bonds are strong and helps keep it together. And also, it's what contributes to that capillary action. Now, it's not here on the slide, but it was in your video. So that adhesion and cohesion that allows capillary action, so the water to move up the stems in plants, that is also due to the polarity of water and its hydrogen bonds. So just something we need to keep in mind. And again, that's called capillary action. And here's just another depiction. Again, this would be a water molecule, 2 hydrogen, 1 oxygen. Remember, our oxygen is negatively charged. It's more electronegative. It's going to attract more electrons. And then, so we have the covalent bonds itself between the hydrogen and the oxygen. Remember, covalent bonds are between 2 nonmetals. So we have our polar covalent bond between the actual molecule, or between the compound itself, and then the molecules interact with each other by also having a hydrogen bond. So this oxygen is so electronegative, it's also going to want to attract the hydrogens on the other water molecules as well. Okay. So the other IMF that we're talking about today is a dipole-dipole, and this occurs between compounds with partially positive sides and partially negative sides. So like, here we have hydrogen chloride, so that would be HCl. That would be one of an example of this. Remember, chlorine is very electronegative, which is going to be, and then we'll leave hydrogen partially positive. Excuse me. Remember, chlorine, he's a halogen. He's on the very right-hand side of the table, right before we get to the noble gases. So his electronegativity is pretty high, which means chlorine is going to have an affinity for those electrons, which means they're going to be attracted to him more so than the hydrogen, which is going to leave, again, chlorine with that partial negative and hydrogen with that partial positive. And this just creates a dipole-dipole, kind of like what we were talking about yesterday, like with water and polarity. So this is just another IMF. This is the middle IMF, meaning that in terms of strength, it's like the middle strength, or the middle in terms of how strong it is. And again, hydrogen chloride would be an example. And then we have our London dispersion forces, and these are also known as LDFs, and these exist between all types of compounds. So it doesn't matter what kind of compound it is, they all have LDFs. So you can guarantee that all compounds will have an LDF. So the more electrons, the stronger the LDF, but at the end of the day, this is the weakest of the IMFs. So here we have iodine, which is I2, because iodine is one of those elements that always exist diatomically. And this, again, this isn't going to have, it's a pretty neutral compound. The electronegativity is 0, right? Because it's the same. So the sharing of the electrons would be equal, and it's just going to have that London dispersion force. So intermolecular forces, again, are weaker than the intramolecular. So intermolecular are going to be LDFs, dipole-dipole, and then hydrogen bonds. So LDF, dipole-dipole, hydrogen are intermolecular. And then intramolecular are the bonds, covalent, ionic, and it's not on here, but metallic would be as well, okay? And then this little like SpongeBob depiction just shows you the order of how strong they are. So LDFs on the bottom, then dipole, dipole, and then hydrogen. So hydrogen is the strongest of the IMFs. The biggest takeaway from today is knowing how hydrogen bonds impact water. So it contributes to that capillary action, cohesion, adhesion, and then also contributes to its high specific heat, meaning that it takes more energy to vaporize the water. So that's the biggest takeaway that I really need you guys to get from this lesson today. Then covalent bonds with the sharing of electrons, and remember, covalent bonds can either be polar covalent or non-polar covalent. We figure that out by doing the difference in electronegativities, and then of course ionic is going to be the strongest. So that's just a little rundown. Again, from today, we just need to know the different types. So this is more of like just a memorization of each of the IMFs, and then knowing how the hydrogen bonds and the polarity affect the properties of water. And that's really what we need to round out this unit. So if you guys have any questions, of course, please reach out and I'll be happy to help. And if not, that is the end of this unit. You guys can go on to your study guide today, and we will review next week and then, of course, test. All right, guys, that's it for today. See you in the next one.